Okay, so welcome everyone to our Earth Day Everyday special webinar this spring. We are very happy to see many of our friends here as well as some new faces, so thank you for joining us. My name is Amy Rowe. I am an agent with Rutgers Cooperative Extension. We're very excited to have Dr. Bob Kopp here with us tonight. But before we get to his talk, we have a couple of things of housekeeping to talk about. Dr. Kopp, if you could please move to the next slide. Okay, so we are going to be doing a poll at the end of this talk to learn what you learned and to see how we can improve our programming. And because you are humans and you can consent to things, we need your consent for us to give you this survey. We also will be following up with you after 6 months to see how this webinar has impacted you and how you will be implementing the actions that are discussed here to see how we're doing and to see the impact that we have. So when you see the poll and you see the consent question, please answer yes. And if you have any questions, you can contact me. My information is here, and we will be happy to talk to you about consent, but we would love it if you would participate in our research studies. So thank you for that. Next slide, please. And we are with Rutgers Cooperative Extension, which is an equal opportunity program provider and employer. So just so you know, we provide programming without discrimination to all races, beliefs, sex, disabilities, ages. We basically provide educational programming for everyone, and we are required to show you this information and to make sure that you are not being discriminated against. Our programs are open to the public, and we are a state government agency, and so we are here to provide programming for everyone, and we do not discriminate. So just want to be clear about that. So thank you. So let's go ahead to your slide, Dr. Kopp, and let me just introduce you, and then we will allow you to go ahead. So we are very excited to have Dr. Bob Kopp. He is a climate scientist at Rutgers University. He is a professor in the Department of Earth and Planetary Sciences, and he also serves as the co-director of the University Office of Climate Action. But he is also an author, a lead author on the Intergovernmental Panel on Climate Change's most recent 6th assessment report, and he is a renowned scientist, and we are very lucky to have him here with us. He has a very impressive resume, but it would take even longer to go through it all. So we would like to spend as much time as possible with Dr. Kopp giving his talk. And so he will be speaking for 30 minutes, and then we will have the 30-minute Q&A session. So please send your questions to me and the other panelists through the chat, and we will make sure to get them answered. So thank you so much for your cooperation, and we will go ahead and have Dr. Kopp talk about the costs of climate change.
Great. Thank you, Amy, and thank you all for taking your evening to be here tonight. I really appreciate the opportunity to join you all and to join Rutgers Cooperative Extension. One of the things I work on my day-to-day life, and you'll see this in some of the talks, is how we get climate information to people who are making decisions, whether that's people in households or people in local governments, people in state governments, people in the private sector. And I think one of the models that we in the climate area have to look through for success in how to do this is cooperative extension and the land grant model. And for 100-some years, cooperative extension and land grant have been working on partnering with communities throughout the country to address problems of the environment and economic development. And I think that land grant spirit and that cooperative extension spirit is really one of the core things we need as we tackle with the problems of climate change, which are going to be with us, for decades and centuries to come, and require, as I'll get to at the end, a real level of engagement and civic engagement at all levels. So let's start with some context. And probably many of you have seen this before, but as you may well know, we're in an unusual time in Earth history. For over 800,000 years, carbon dioxide concentrations in the atmosphere have stayed between about 180 parts per million during periods we call ice ages and 300 parts per million during warmer periods we call interglacials. This plot here is showing you carbon dioxide concentrations in the atmosphere has reconstructed from bubbles of air trapped in ice core. And you can see this up and down, so ice age, interglacial, sawtooth pattern that went up until about 200 years ago. And now that's changed. In 1913, carbon dioxide concentrations surpassed 300 parts per million. In spring 2014, they surpassed 400 parts per million for the first time in what was probably about 3 million years. And they are going to be above 400 parts per million for all of our lifetimes. So I want to take a somewhat more detailed look at this. So let's just zoom in on that last 200 some years. So in 1750, before the Industrial Revolution, carbon dioxide concentrations in our atmosphere were around 277 parts per million. Over the next century, primarily as a result of the burning of coal, carbon dioxide concentrations climbed to around 287 parts per million. Over the next 50 years to 296 parts per million. Over the next 50 years to 311 parts per million. So between 1750 and 1950, we climbed from 277 to 311 parts per million. And then things really start to pick up. By 1988, and this was when Jim Hansen and Al Gore were having their hearings in Congress, carbon dioxide concentrations had exceeded 350 parts per million. Now we are about 417 parts per million. So carbon dioxide concentrations have risen about as much since the late 1980s as in the previous 230 years. So this is really important to keep in mind. Though you often hear climate change talked about as a problem of the industrial era, most of it is a problem of my lifetime and of the post-Cold War era. So why is that? The reason's simple. Most of the carbon dioxide ever emitted by burning fossil fuels has been emitted since the collapse of the Soviet Union. Let's look at this. This is cumulative fossil emissions. This is how much CO2 we have taken from fossil fuels, burnt and dumped in the atmosphere starting in 1750. So between 1750 and 1850, a total of 5 billion tons of CO2 was dumped in the atmosphere. Between 1750 and 1900, 45 billion tons. And just by reference, in 2021 alone, we emitted about 36 billion tons of CO2. So about as much between 1750 and 1900 as in last year. Between 1750 and 1950, 230 billion tons. Between 1750 and 1991, 830 billion tons, right? So that's the entire period from the start of the Industrial Revolution till the end of the Cold War. Between 1750 and 2020, almost 1,700 billion tons. So about as much from 1991 to 2020 as from 1750 to 1991. And as a result of these emissions, our planet is running a fever. I know these are a lot of charts, but they're important. This plot is showing you how much global average temperature on the planet has changed since the late 19th century up until 2021. This is NASA data. And what you can see is that we really start to pick up in the 1920s. There's a slower period in the 1940s, 1960s, and then the sustained rise starting around 1980. Between 1980 and 2020, global average temperature rose at a rate of about 0.2 of a degree Celsius or 0.3 of a degree Fahrenheit per decade. And the last 7 years are most likely the warmest 7 years in the observational record, with temperature averaging more than 1.1 degrees Celsius or 2 degrees Fahrenheit above the late 19th century average. So 40 years ago, when we first started having congressional hearings on climate change, we might have thought of climate change as an issue for the distant future, but it no longer is. It's already affecting people throughout the world, including people here in New Jersey. And I want to give you a few examples of changes we are seeing both in the physical environment and in our economic and social systems that we can attribute to the effects of climate change. So first of all, here in New Jersey, we see temperatures rising faster than the global average. This is average annual temperature in New Jersey starting in 1895. And what we see is that average annual temperature today is now nearly 3.5 degrees Fahrenheit or 2 degrees Celsius higher than in the early 1900s. So 1.1 degrees Celsius of global warming, but almost 2 degrees here in New Jersey. And we are seeing rain and snowfall becoming more intense because when you have a warmer atmosphere, it can hold more water vapor. And so when you have rain and snowfall coming, it comes in more intense bursts. So we see that over 1958 to 2016, according to this figure from the National Climate Assessment, the amount of rainfall falling in intense events, that is days exceeding the 99th percentile, has grown by more than 50% in the US Northeast. And I'll get to some of the impacts of that in a second. Sea level is also rising, and it's rising faster in New Jersey than the global average. So since 1911, global average sea level has risen by about 8 inches. That's a result of partially the oceans expanding as they warm up, and partially glaciers and ice at the pole melting as the planet heats up. Over the same period of time, sea level in coastal New Jersey has risen by about 18 inches. The difference is largely due to the motion of the land. About 7 inches due to the natural sinking of the land associated with the ongoing response of our region to the end of the last ice age, and about 3 inches due to the sands on the coastal plain compacting due to the result of groundwater pumping. So 1.5 feet of sea level rise on our shores since 1911. So what are the consequences of that for human beings? Well, when you have a warmer planet, it's pretty straightforward physics that when you have a heat wave, it's going to be a more intense heat wave. One of the earliest studies looking at the effects of climate change on heat waves looked at the 2003 European heat wave, which killed about 70,000 people, and found that the human contribution to climate change had made that event about 3 times more likely. And without that human contribution, there would have been about 2/3 fewer deaths there. Over the decade between 2003 and 2013, it became about 3 times more likely again, and it's continued to become more likely since then. So this sort of rare event is more than 10 times more likely now than it would have been without the human contribution to sea level rise. This is a photo of the area near Houston, Port Arthur, Texas, after Hurricane Harvey. Right? And so you had a lot of intense rain-driven flooding during Hurricane Harvey. And one of the things I just reminded you of, right, is the warmer atmosphere, you get more intense rainfall. Well, Hurricane Harvey's intense rainfall, more than about 50 inches in some areas, was made about 3 times more likely as a result of the fact that this was taking place in a climate change planet with a warmer atmosphere. A little closer to home, this is, of course, Route 18 in New Brunswick. This is a photo from September 1st, right after Hurricane Ida. I haven't seen the same sort of quantitative analyses, quantitative attribution analyses, we called it, that I mentioned for Hurricane Harvey. But I don't really need to make this conclusion, because the basic physics tells us that Hurricane Ida's flooding was made more intense by climate change. I was pretty lucky. We only got about 2 inches of flooding in our basement during Ida. Some of the people in our area got about 2 feet. But because we were on that margin, I actually feel pretty confident telling you that my basement affirmatively would not have flooded had it not been for the effects of climate change in the way that it made rainfall more intense. Now, when we look at the coast, right, we have higher sea levels. That means a few things. So one thing higher average sea levels mean is that it requires less of a tide to cause the same amount of flooding. So high tide flooding is becoming more common. This is a picture from Ventnor, New Jersey, of an unusually high tide in November 2017, collected as part of a citizen science project led by the Jacques Cousteau National Estuarine Research Reserve. And we can see that sea level rise is making high tide flooding more common. The number of high tide flooding days in Atlantic City have increased from less than 1 per year on average in the 1950s to over 8 per year on the last decade, a period over which sea level rose by about 9 inches on the shore. A study that we did with our collaborators at Berkeley and Chicago and Rhodium Group came out a couple of years ago, shows that due to sea level rise, about 27,000 more New Jersey properties experience flooding once a year on average than would have in the 1980s. So for instance, in Ocean County in the 1980s, about 19,000 properties flooded in a typical year, now around 32,000 do. This is Ocean, Cape May, Atlantic, Monmouth are where most of the properties are. Second, though, with higher sea levels, when you get a big storm, you get more extensive flooding and you get more expensive flooding. A study that we did together with collaborators at Climate Central, a nonprofit based in Princeton, and Stevens Institute of Technology, shows that the human contribution to sea level rise in New Jersey was responsible for about 13% or $8 billion of the property damage caused by Sandy in New York and New Jersey, and that about 70,000 people in our region wouldn't have been flooded during Sandy had it not been for that human contribution to sea level change. And due to a combination of sea level rise and climate change driven changes in hurricanes, New Jersey's average annual losses from hurricanes are increasing by about $1 billion since the 1980s. And this chart here is showing you where that's happening. So the dominant increase, about half of this is in Hudson County, followed by Bergen and Cape May County, right? So this is because we have the higher sea levels, so the storms flood more extensively. And then in addition, there's been some intensification of hurricanes over this time period that have to do actually primarily with changes in aerosol pollution. So that's where we are today. As we look to the future, the first thing we have to grapple with is that every additional amount of greenhouse gas we emit makes climate change more severe. So all of those impacts we've talked about already, every time we emit another ton of CO2 in the atmosphere, we turn the knob up a little. Roughly, we get about 0.4 degrees Celsius or 0.7 of a degree Fahrenheit of warming for every trillion tons of carbon dioxide we dump into the atmosphere. That gives us about 0.2 of a degree Celsius or a little less than 0.4 of a degree Fahrenheit per decade of warming at our current rates of emission. So when we think about the potential futures we might face, one of the key drivers of the uncertainty of the range of possible futures is the range of possible human emissions. That's driven by our politics, it's driven by our economics, it's driven by our technology. I want you to think back to the 1980s. I was a little kid. Al Gore was convening some of the first congressional hearings on climate change. Each year, humans were pumping about 20 billion metric tons of carbon dioxide into the atmosphere. Right, so this is what this plot is showing you is the tons of carbon dioxide released into the atmosphere per year from 1960 till 1990. As of the mid 1980s, since the start of the Industrial Revolutions, humans had emitted about 600 billion metric tons of carbon dioxide from fossil fuels altogether, which together with emissions from deforestation and other greenhouse gases had raised global average temperature by about 0.4 of a degree Celsius or 0.7 of a degree Fahrenheit. Now, suppose we had had a major policy change. Suppose that starting in 1992, which was the year when the UN Framework Convention on Climate Change was signed and the series of annual climate change negotiations began. Suppose then we had gotten global carbon dioxide emissions on a downward trajectory, something like this trajectory A shown here. We could have had about 90 years to get global emissions to zero and still have a good chance of stabilizing the climate at well below 2 degrees Celsius, which was one of the goals agreed to in the 2015 Paris Agreement. This trajectory shown here would have led to a likely warming of about 1.8 degrees Celsius, a little over 3 degrees Fahrenheit above the late 19th century by the end of the century. But we didn't get on that future. Instead, carbon dioxide emissions continued climbing at a quite rapid rate in the 1990s and the 2000s, at a slower rate over the last decade. And now nearly 40 billion tons of fossil carbon dioxide are dumped into the air every year. As a consequence, the planet's temperature has increased by about 0.8 of a degree Celsius since the mid-1980s. And we are feeling the consequences that I talked about earlier, right? So about twice as much warming since the mid-1980s as up to the mid-1980s. Now, let's talk about another future that probably isn't going to happen. What 15 years ago we might have called business as usual, shown here as future D. If over the last decade, emissions had continued growing at the same rate that they did in the 90s and the 2000s, we would be something on something like this trajectory, on track for about 4 degrees Celsius or 7 degrees Fahrenheit of warming by the end of the century. But fortunately, that's not quite the trajectory we are. Emissions growth has been slowing as a result of a combination of policy and the market-driven retirement of coal and growth of renewable energy. And this is a beam of hope I want you to appreciate. We may not have had as aggressive a policy as many of us would have liked to see, but there has been a lot of progress. In the United States, the Clean Power Plan, which was the Obama-era plan to regulate carbon dioxide emissions from electricity, never went into effect. It was stopped by the Trump administration and the courts. But we've already met, as of 2020, the emissions reduction goal for the electricity sector that the Clean Power Plan set for 2030. So the whole litigation was a little bit silly because it was a non-binding policy anyways. We were already doing better than the policy set out. But we're not on this future D at the moment. And it will require a change of policy, a reversion back to old trends in order for us to be there. So it is still possible to achieve the Paris Agreement goal of limiting warming to 2 degrees Celsius. But instead of getting to zero emissions in 90 years, like we might have been able to do in 1992, we have about 30. Alternatively, we could, as shown in pathway B, we could take a little bit longer and hope that we have the right technology and right land use policies in place by the end of the century. So we're actually pulling carbon dioxide out of the atmosphere, not dumping it in. This is what we'll call future B. Same temperature outcomes as future A, not as easy as future A, faster emissions reductions required, but it's still a pretty optimistic future. And here's future C. This is, of the suite I'm showing you, the closest to current policy. And it puts us on track for close to 3 degrees Celsius or 5 degrees Fahrenheit of warming by the end of the century. Now we're here in 2022. And when I think about projections for the next 78 years, I think of my son, who's a toddler today. I hope he will be around in 2100. I hope he'll be in his 80s at the end of the century. So when we look at these trajectories, first, I think of his life, right? Is his life going to be future B or future C? Or, God forbid, future D? Whatever course we're on won't affect how the climate changes over the next decade. The benefits of reducing our emissions in terms of planetary climate will start to accrue in the 2030s. But the world in future B and future C nonetheless look very different. By 2030, it will be clear whether we've managed to turn a corner. In future B, the urgent calls for climate action will have made an impact. Massive infrastructural changes will have led global emissions to fall substantially. In future C, on the other hand, policy inertia will keep emissions stalled around their current levels. Clean energy technology will continue to progress, but not fast enough to drive systemic change. And the Paris Agreement goals will become increasingly out of reach. By the time my son turns 40, around 2060, and is the same age that I am today, the two climate futures will markedly differ. In future B, large-scale investments and a booming carbon-free economy will put us within striking range of net zero carbon dioxide emissions and the associated stabilizing of the global climate. Heat waves, flooding, wildfires, droughts will still be worse than in 2020 or 2030, and the oceans will still rise for many centuries to come, but we will have stabilized some of those changes and slowed down others, and we'll be able to develop the systems to manage the elevated risk. In future C, emissions will have continued at around their current level. Temperatures will be blowing past the international 2 degrees target with little slowdown in sight. and the impacts of climate change on health, on agriculture, on energy, on economic growth, on violent conflict, and on many other aspects of life will continue to worsen and will fall disproportionately on the poorer parts of our country and of the world. So we have to make collective choices about both how to lower our emissions and how to adapt to the changes we don't avoid. And these are both projects that I'm working on in various ways at Rutgers that I want to tell you about. But we first have to acknowledge that we aren't working together to manage our existing climate risks very well in the climate we have today. We are seeing a slowdown and erosion of our governance institutions. Thus, think about Hurricane Maria, right? Struck Puerto Rico in September 2017, right? A year later, there was still a lot of trouble getting aid to Puerto Rico. A year and a half later, still a lot of trouble getting aid being stalled in Congress and the president's office. Still 2 years later, still almost 4 years later, there was still a challenge to get the mutual aid that we might expect that has a single country we would provide to one another out in terms of disaster relief. So the facts that we have trouble getting our act together and responding in the aftermath of a disaster, a climate-driven disaster, right now, that worries me for our ability to make the decisions that we need to make in order to adapt to the impacts that we're experiencing and that are growing more intense. But let's talk about what we have to decide among. What's in our toolkit? Let's think about one particular type of climate impact that's of importance to us in New Jersey, which is the effects of sea level rise and flooding on our communities. So what can we think about? What's in our toolkit for adaptation? Well, one of the things in our toolkit is accommodation. For instance, elevating buildings, which is becoming increasingly common and increasingly required in our shore communities. But we have to remember, these are sort of individual decisions, but no house is an island. And so we have to make sure that if we're going after accommodation as a strategy, we're not just thinking about the individual buildings and their flood, but also the critical infrastructure. It's great if you're in house number 259 here, if there's a flood and if hopefully you've got your car out of the way, but not much damage there. But it's not so great if you're in your house and your sewer and electric don't work, because those haven't been adjusted to accommodate more increased flooding. Do we build hard protective structure? This is a diagram of the East Side Coastal Resiliency Project in Manhattan, which is being actively built right now. And these sorts of hard protective structures can make a lot of sense in areas where you've got dense population, dense property, people are going to be around for a while, and particularly where you don't have the ability to create space for nature-based solutions. But as Hurricane Katrina should remind us, we also have to plan for those occasions when hard protections like levees fail. And one of the challenges with hard protection, if you don't do this, is that actually building flood walls and levees can increase your vulnerability. You can actually get more people in this area that in general is safe. But if protections fail, you've concentrated risk. So we need to recognize that nothing is perfect. Or do we relocate in some places to higher ground? As a number of communities like Oakwood Beach and Staten Island chose here, and some neighborhoods in Woodbridge after Sandy, do we choose to relocate to higher ground? And when do we do that, right? This has to be acknowledged as being part of the toolkit. But you don't want to bring out the biggest hammer in your toolkit if all you have is a small nail, right? So we need to be able to make decisions that are informed by science, recognizing that there's a broad range of potential futures we're facing, which will depend in part on the range of possible emissions we experience, and in part on things we're still learning about the climate system, like how ice sheets and oceans interact. And so we want to think about these options in areas where it might be necessary, but we also want to make sure that we stage our options, that we have deliberative processes, that as we think about how to knit these together, we're creating a vision for our communities and focusing on having healthy and vibrant communities for as long as possible, while recognizing that, what are the warning signs that we need to think about more drastic action. We don't want to take the most expensive and disruptive actions now, but we also can't take them off the table. So in order to have these decision-making processes, we need people who are experts at facilitating science-informed, deliberative community processes. And this is something that we're trying to put together at Rutgers. One of the ways we're doing this is through our Coastal Climate Risk and Resilience Initiative, which is a graduate training program that brings natural scientists, social scientists, engineers, and urban planners together with one another and with coastal stakeholders, that teaches our graduate students to communicate with stakeholders and to work with them on real-world resilience challenges. For instance, last year, our students helped Union Beach develop a resilience plan. Our goal with this program is to build the next generations of scientists and practitioners who will be able to work with communities to help improve the science we need for coastal adaptation and apply that science so that we can have science-informed, community-driven climate risk management. Building off of C2R2, we've launched in the last fall a new project, a National Science Foundation project called the Megalopolitan Coastal Transformation Hub. This is a 12-university consortium, a 5-year initial period of funding with 3 goals. One is to advance the scientific understanding of how changing coastal climate hazards, changing coastal landforms, and human decisions, both at the household and individual level and at the municipal level and in markets, interact to shape climate risk. So, if we implement a particular adaptation solution, how is that going to affect the desirability of our communities? How is that going to affect our property base? How is that going to feed back on overall community well-being? And how do we use our understanding of the system to facilitate flexible, equitable, and robust long-term planning to manage climate risks in urban megaregions like the New York City, New Jersey, Philadelphia region? We're trying to build a model of academic and stakeholder partnership that provides insights for just, equitable, and inclusive climate action in diverse coastal urban megaregions around the world. And you can read more about our work in MOC at coastalhub.org. But however we choose to adapt, the starting point is climate change mitigation. And right now, we've got a pretty large gap between where we need to be if we want to hit the ambitious targets in the Paris Agreement and where current pledges and targets and policies get us. We're roughly on trajectory right now for level emissions, as I said, and we need to be on a trajectory for declining emissions if we want to get to a stable climate. So I just want to plug another thing we're doing at Rutgers. In the fall, President Holloway adopted our first University Climate Action Plan and set up the University Office of Climate Action, which I co-direct. And he charged us with overseeing Rutgers Climate Action Plan, whose overlying goal is to mobilize Rutgers as an academic institution that does research, teaching, and community engagement, and also as a large operational and economic player in New Jersey to advance just and equitable climate solutions and to help the nation achieve net zero greenhouse gas emissions no later than 2050, consistent with the Paris Agreement goals. And so we're committed to achieving a carbon neutral campus by 2040, to advancing just and equitable campus and community climate adaptation partnerships, to integrating climate action around mitigation and adaptation into academics at Rutgers, into student and faculty and staff life at Rutgers, and into university policy. And in so doing, build a globally leading model of campus, community, state partnerships for climate action. I don't want to go into detail in our pathway to carbon neutrality, but I do want to mention some of the things we're thinking of because I think they're this is a toolkit that other organizations, including perhaps some of yours, and even in your household to some extent, might think of applying, right? So what are the parts of our pathway to carbon neutrality? Well, one, we've got to reduce and ultimately eliminate our on-campus burning of fossil fuels. right? Some of that is our buses, but most of that is in our heating and electricity cogeneration system, right? Analogous to the natural gas furnaces and water heaters you probably have in your house, right? So we need to transition away from those natural gas, fossil natural gas processes over the next 18 years. Second, we buy electricity off the grid. We generate some on campus through both fossil fuel burning and solar, but we buy most of it off the grid. And we need to be buying that from sources that are carbon neutral. And so we've committed to eliminating emissions from grid electricity by 2030. Third, those are the sources most directly under our control, but we also have emissions associated with things like the commuting people do to come to campus, and that's a substantial chunk of our emissions. Business travel and supply chain associated emissions. So when we buy food, when we buy other objects, right, there's emissions associated with those supply chains. And those are less directly under our control, but through conscious policies around telecommuting, around incentivizing electric vehicles, around conscious procurement, we can reduce those emissions as well. Fourth, we need to, in the long run, right, our global plan calls on us to be pulling more carbon dioxide out of the atmosphere than we're putting in. And so we want to start doing that on campus through better land use policies, through innovative building materials that sequester carbon dioxide, and through investing in off-campus projects that we ourselves run. Now, one of the things that's many organizations, and you can do as well, to help reduce your emissions is pay other people to reduce their emissions, what's called third-party offsets. When we put together our climate action plan, we recognize we might have to do some of that, particularly to help deal with some of these emissions like commuting and the supply chain that are less directly under our control. But we view that as a complementary strategy of last resort, a way to spend our money after we put major efforts into reducing our on-campus emissions. And finally, in that vein of getting at these emissions not directly under our control, we're also committed to acting as an economic player and as an institution to advocate for addressing the societal choices that underlie the indirect emissions and things like supply chain and community. So that's our pathway to carbon neutrality. And I think you can infer some individual things from that. So what more specifically can you do? Well, I'd like, as I said, sort of alluded to, this is really a problem that requires collective deliberative processes. And I am concerned because our democracy is not at its peak health. And we need a healthier and more democracy with an engaged citizenry in order to solve the problem. We have the technologies. We know what sort of policies could get there, but we have to make our governance institution work. And so the number one thing I want to ask you to do is to be active citizens, not just by voting, although you certainly should, not just by following national politics, although you certainly should, but in your local communities, your state community, and in your work communities, just like we're doing at Rutgers. And secondly, if that's a little hard, the other thing you can do is take that bit of our nation's infrastructure that is more directly under your control. If you're a homeowner, for instance, that's your house, and electrify your bit of the nation's infrastructure, decouple it from our fossil gas and fossil oil infrastructure, right? Even though our electricity system isn't fully decarbonized, by shifting from direct burning of natural gas or oil to electrification, it means you can take advantage of the fact that actually the technologies to get us to a decarbonized electric system are pretty clear and achievable in a more accelerated fashion than other ways of replacing direct fuel use. And so there are a lot of things you can do. The number one and two uses of fossil gas in your house are probably your heating and your hot water heater. But I want to direct you to this very helpful guide from an organization called Rewire America that goes through 10 different things you can work on to decouple your home from our fossil infrastructure. And so I want to close by thanking you. I look forward to the Q&A and look forward to your engagement as active citizens in this big challenge we have in front of us if we're to get on that ambitious trajectory that leads to climate stability.
Okay, well, thank you, Bob. We do have some questions rolling in, but we really appreciate you speaking very upfront about the challenges, but also giving us some hope for sure. But we've got some questions, so let's just dive in because we know everyone's time is precious. So one of the questions was about the impact of other countries like China and India. It seems like the US has done a lot of improvements in CO2 emissions, but how much has the rest of the world done?
Yeah, so that figure I showed you in terms of CO2 emissions, the different scenarios, those are global emissions, right? So it's global emissions that have close to plateaued over the last decade. And it's also, it's certainly true that it was over the 1990s and 2000, one of the major drivers of the rapid growth in emissions was China going from being a very poor country to being a middle income country. At this point, China's tricky. On the one hand, they are one of the largest investors in the world in clean energy and have a lot to do with the learning that has made renewable energy so cost competitive today, right? If you were to build a new power plant right now, it is in many cases cheaper to build a new solar power plant than anywhere else. And China has a lot to do with that dramatic reduction in prices that has happened over the last 20 because they invested so much in it. On the other hand, at this point, per capita emissions in China are comparable to those in Europe. And so it's certainly important for them to transition to being a declining nation. They have committed to that. I think they've had a 2060 target. And we are still per capita more than twice the emissions of China. So we have somewhat further to go per capita. I mean, China is by far the largest emitter in the world, but they're also about 3 times larger than us in terms of size. So you would expect that to be the case. India is still substantially less per capita than China or Europe. They are still a quite, much of them in India is still quite poor. There is still a substantial fraction of India that doesn't have access to grid electricity. So they're going to be a little further behind. But it is really incumbent, I think, on China, on the US and Europe as the nations that have propelled their economic growth with fossil fuel for the last 150 years to take a leading role. And I think it's fair to say that it is the US and Europe where there have been actually declining emissions and not just stabilizing.
Okay, thank you. So the next question is about the New Jersey coastline. So it seems like New Jersey is at risk of major economic damage due to climate change. So will the coastline be lost? Is it just going to become a sacrifice zone? What are your thoughts on that?
I don't think there is a single answer to that question. I think that is going to be different from community to community. I mean, there's certainly, as I said, like Atlantic City and the Jersey Shore, like the high tide flooding that happens, 8 days a year right now, that will probably be happening close to 100 days per year by the middle of the century. So do we accommodate? Do we, well, probably the Jersey Shore, most of it's going to be hard to build effective hard protection structures. There's space for nature-based solutions, creating more space, or do we relocate? And I think you have to look at that case by case. I don't think there is a single solution, and I don't think the answer can be imposed from above either. I think we actually, that's why I think governance institutions and democratic processes and community engagement are so important. And I would say, because we are here with cooperative extension, I mean, I think this is a really important part of the cooperative extension tradition that I hope, we are reaching into to some extent at a small scale with initiatives at Rutgers like MOC and like the New Jersey Climate Change Resource Center, and I would love to see us do more of. If you read the the historical accounts and evaluations of, say, community extension during the period between World War I and World War II, it's really talked about as a community organizing mission, a mission that invigorated the democratic tradition and community engagement. And I think that's the sort of thing we need in every community to ensure that communities in our democracy are able to appropriately adapt to climate change. So I don't want to give you an answer, because I don't think it's my position to come in and say what yes or no. I can say, like, yeah, if we're on that high emissions trajectory, eventually that will happen. Right. So there's just feedback between what we do at the local scale and what we do at the global scale. But you don't want to act as though the worst case is you neither want to act as though the worst case is a certainty, nor act as though the worst case is impossible.
Okay, well, thank you. And I'd like to remind everyone that cooperative extension is in every county in this state. And so we are working very hard to engage the community. And actually, that's a good segue to our next question, that climate change action has become such a political issue, pitting liberals against conservatives. How do we make this less of a hot button political issue and more a problem that we can all solve together?
Yeah, I mean, I think I almost view this as less a climate issue at this point and more a democracy issue, because you can say that at a national scale about almost anything that has become a hot button polarized issue. So I think core of that has to be we need really strong national policy. Like, we can't avoid that, but I think we also have to really put our effort in other things as well, in our local communities, in our workplaces, places where we can engage with people rather than caricatures of people, where we can see people face to face as opposed to in 140 characters. I think that this is, honestly, the thing that worries me the most. As I said, we know the economics, we know the technology, we know sort of broadly what needs to be done, but the hard problem is the politics of getting this done. And I mean, if we can't if we can't even agree on our voting systems, then I think we have, it's going to be hard to agree on hard policies. So I think figuring out how we fix our democracy and restore trust, like that unfortunately I think is the biggest challenge in addressing climate change. But at a local scale, you're addressed by treating people as people and having discussions with people as people, not as caricatures, and not having these abstractions that you hear on Twitter.
All right, thank you. So next question is, are there any policies being pushed to mandate green building for new builds in New Jersey? I consistently see new high rises and residential homes go up without LEED certification or any kind of green building considerations.
That's a good question. Actually, I'd have to look up what the policies are. So at Rutgers, all of our buildings are supposed to meet LEED Silver standards, and we're looking at tightening that. I do hope as we do things at Rutgers, like revisit our building standards. But in fact, many of the things we're doing, I'm hoping what we do at Rutgers can be a resource for other people who want a model to follow. But at the moment, I'm not aware of.
Okay, so it sounds like many homeowners in coastal New Jersey towns will have to move inland. Are the county, state, and local governments making plans so that that relocation occurs in an organized, planned way rather than a chaotic way?
Yeah, so what I'm going to say is that maybe a little bit slowly. Climate change is supposed to be now incorporated into master plans, but this is a new requirement. by and large in this country, and this is true in New Jersey as well, most planning is post-disaster and not pre-disaster. And at least I think we recognize that that's a problem, and the state, I think, is working to change that. There's a number of new requirements for adaptation plans at a municipal level. I think one of the challenges is we have 535 municipalities in New Jersey. We're a very decentralized state. And we don't have, there's a requirement to consider some of these things, but not necessarily capacity to consider them. And so I think that's building up that capacity is going to be a really important thing, right? Right now, we have programs like Blue Acres that can buy out places that get repetitive flooding or after a disaster. But nonetheless, and I think since over the last decade, there's roughly been 800 buyouts through Blue Acres, and a Climate Central Zillow study 3 or 4 years ago showed that over a comparable period of time, there have been about 3,000 or 4,000 new homes built in the area that's going to be in the annual floodplain in 2050. So I think New Jersey is actually in many ways further along than other states in what towns are being asked to do. These are relatively new requirements, and to some extent, it would be fair to call them unfunded mandates. I hope that through things like the New Jersey Climate Change Resource Center, which is based at Rutgers, we can help with that. But the New Jersey Climate Change Resource Center is 4 people, gets $500,000 a year from the state, and that's not quite adequate for 535 municipalities. So there's a scale issue, right? We are not adequately invested in human capacity. And as we see more investment in infrastructure, I think that's going to be a really big challenge, right? I mean, it's great to put a lot of money on infrastructure. You also need to invest in the people.
Okay, thank you. I'm going to take a minute. I'm going to launch our survey so that you guys can take this while we're still talking and before everyone runs out the door. So I'm going to launch this. Please take a couple minutes and take a look at that before you go. And in the meantime, so someone wants to know, do you have projections on the cost of climate change on New Jersey agriculture production? And do you think that cost can that cost drive policy change in New Jersey? Excuse me.
So that's a good question. I don't. The work we've done in the Climate Impact Lab on agriculture has been focused on sort of large staple crops, like things like corn, wheat, soy, and so forth, not specialty crops, fruits and vegetables like we focus on in New Jersey. Though I think I don't know, and probably somebody at Rutgers does know what is out there in terms of specialty crops that we grow here. I hope that will drive policy change with respect to the agricultural sector in New Jersey. I sort of not so sure it will drive broader change, but certainly, farmers are very close to the weather and understand that it's changing. And so I think that's certainly something that should be looked at.
Okay, thank you. And what are your thoughts on the climate future for the western part of the state, like Sussex and Warren counties, where there are higher elevations and they're seeing much more extreme wind and rain events as opposed to the coast?
Yeah, I mean, we're seeing more intense, well, so let's not break that out into wind and rain. So rain events, as I indicate, right, that's clear attribution to climate change. Wind events, it's a little, the science is a little less clear, but there is some suggestions that sort of the conditions that lead to things like intense thunderstorms are affected by climate change. But if we just focus on intense flooding, well, you don't have to be, look at Hurricane Ida, right? That was more in central New Jersey, but that was a rain-driven flooding, right? And this is going to be a common problem everywhere. Even areas that experience more drought also are, which is not so much New Jersey, are also areas that experience more intense rainfall when it comes. And so that rain-driven flooding is absolutely something that we need to be adapting to.
Okay, thank you. So another question, lots of questions. It was quiet and now they're rolling in. Can you talk about the possibility of seeing more focus on green roofs in New Jersey to help with stormwater management as well as urban heat islands? Have you seen any movement on this? I know there is some new DEP stormwater management regulations, but they're not all mandatory. What do you think about green infrastructure and stormwater management related to climate change?
Yeah, so I don't know about the policy directions on green roofs. That's something that should be in the toolkit. More broadly, nature-based solutions can be very useful in many circumstances, particularly where you have the space to accommodate them. Green roofs is nice because you actually don't need that much space. But when we look at like coastal adaptation with like oyster reefs or creating salt marshes, like those are useful tools in certain cases in dealing with things like protecting from wave energy. In general, isn't it time to do more? The answer is always yes. But I think it'll also come back to the capacity issue. There's lots of great things we can do. And I think, I was moderated a panel on Thursday with somebody from the state level in North Carolina and the local level in San Francisco. And the person from the state of North Carolina, Tankford Miller, brought up this phrase, random acts of resilience. And I think that's a really useful thing to keep in mind. We need to be strategic about what we do rather than just saying, okay, this is this and this, and these solutions look good, and here's an opportunity for funding, so we're going to grab some of that, and not figure out, okay, well, what is our strategy? Like what is our future for our community? What do we need to make that happen, and how do these pieces fit together? And that's one of these things where I said human capacity is really important. You can't do strategic planning unless you have human capacity to do it. But if we don't have strategic planning, we can get things like maladaptation, where we make things that, decisions that, maybe are useful in the short term, but disadvantageous in the long run, or maybe are just disadvantageous in both the short and long run, because they, reduce one risk but create other risks. In general, if you ask me about any one thing, I'm going to say we need strategies, and we need the ability to create strategies at all levels.
Yeah, that makes sense for sure. So how big of a role should climate engineering play in our efforts to counter climate change?
So let me define climate engineering. So this is a term that encompasses at least two different types of things, actually more, but the two big things people talk about are carbon dioxide removal, which is pulling carbon dioxide out of the atmosphere, and solar radiation management, which is changing how reflective the earth is to reflect the sunlight away. Carbon dioxide removal probably needs to take a very large role. I mean, it is, we'll have issues, among other things. We don't know that we can do it at scale, but it involves the same knob that we have been turning all the way in one direction for the last 250 years and trying to pull it back a little bit. That there's local environmental challenges, like what do you do with the CO2 you put out of the atmosphere, but globally it seems it's relatively safe. Solar radiation management, we have at Rutgers Alan Robach, who's one of the world's expert on this, and on the really expert on all the reasons why it's probably a very bad idea. Whether you want it in the toolkit at all, I think is an open question. It's a way of creating a lot of new global risks while reducing global surface temperature and temperatures around the world. There are some forms of solar radiation management, like reflective roofs, that are great. Make your roof more reflective. It reduces the amount of energy you need to cool your building. That's great. Slightly reduces the albedo of the planet, but it's a local effect. like global scale solar radiation management, like putting pollution in the stratosphere to reflect the sunlight's away. I think, I'm not going to say it's something you would never want to do, but it's something you have to be very deliberate about. And I don't think anybody, even the people who support researching it, would say you would want to deploy it right now. I think we also need to be careful about thinking about it as an emergency option for, what if something goes radically wrong in the climate system, where we sometimes call tipping points, because it probably is not going to be able to help out with those tipping points. So where you might see it, is, maybe in some of these hotter worlds, if people are dying from extreme heat waves, some people they'll say like India getting fed up with climate inaction and doing geoengineering, or something of that sort. I'm all for thinking about things, but you got to be very cautious when you're having a small, something a small number of people do that affects the global climate. So that was a very circuitous answer, but I think if that's the sort of answer that something like solar radiation management merits at the moment.
Okay, so we still have a couple more questions. I don't know what your time frame is here. We are at 7:30. Just want to check in with you. Can you take a couple more questions or?
Sure, I can do that.
Okay, so how effective are regional packs, compacts like RGGI and TCIP?
Yeah, so our RGGI is a greenhouse gas cap and trade program for the power sector in the Northeast. It's been a valuable program in the States, mostly. I think I'd have to go back and refresh my memory on whether it's been that binding in terms of emissions. Many states in the Northeast and throughout the U.S. have things like renewable portfolio standards, which set a certain target for the amount of solar energy generated, and those have been the primary policy drivers of decarbonization of the electricity system in most of these states. But RGGI contributes and is also a revenue generating mechanism, and that revenue it gets recycled into things like energy efficiency and other pro-climate measures. So I think it's been effective in that regard. Transportation Climate Initiative. I think that's still at a pretty early stage. You can correct me if I'm wrong, but I think that was sort of an attempt by the states that are involved in things like RGGI to do something in the transportation sector. But I think it'd be great if we could do things nationally. If we can't do things nationally, it's always better to coordinate over a broader region. But yeah, so I think that, some national policies that involve coordination among multiple states are always good. The U.S. Climate Alliance is another thing to look at, not a policy so much as a coalition of states that are trying to do things and share best practices.
Okay. And what do you think of trees and their part in climate change mitigation?
Yeah, I mean, I think broadly we should be thinking of nature-based solutions as the question is, can we think of that as part of our infrastructure? I think nature-based solutions should be part of our infrastructure, or thought of as part of our infrastructure. Right now, globally, deforestation, is a major contributor to climate change. Something like 10% of our global carbon dioxide emissions are associated with deforestation, right? And we need to flip that sign. We need afforestation, right? The net removal of carbon dioxide from the atmosphere into the biosphere. And so, that's something certainly that, on the mitigation side is quite important.
Okay, then we have a naysayer here about electrifying your home. Do you think that if everyone electrified their home in New Jersey, that we would have rolling blackouts and the blackout issues that are seen on the West Coast?
So the blackouts on the West Coast are climate hazard driven, right? So wildfire driven, or in the case of Texas, which is not in the West Coast, that the blackouts there were driven by winter storms and that was a failure of the natural gas power plants to weatherize. So Yeah, I mean, I think resilience is an important goal, but I think that the way to achieve that that's best is right through decentralized power sources, right? So if you electrify your home and you want to be able to decouple from the grid, you can put in a battery and do that. I assume you're talking about the sort of weather resilience. Yeah, I mean, as I say, ultimately, right, and look, there's not another option on the table for your home if at the moment in a decarbonized future. People, there has been some work that might work particularly in urban regions on expanding essentially community heat pumps, with community ground source heat pumps, which some college campuses have in various forms as well. So that can be an alternative, but you know, we have to transition away from fossil gas if we're going to stabilize the climate. There's not really a option otherwise there, right? I mean, maybe in the power sector you could keep some because you could have carbon capture and storage, but there is no alternative at a household level for keeping direct burning of fossil fuels that's consistent with a stable climate.
Okay, well, you seem to have answered all the questions that have come in, so thank you so much for staying a little bit longer to get those answered. We really appreciate this very easy to follow simplification of a complicated issue. We really appreciate you coming for our special live Earth Day Everyday webinar. We do have some videos that are on our website that can be rewatched. You can watch those at your leisure, and we are recycling content, so please go back and look at some of our past webinars to learn about all kinds of environmental related issues and what you can do at your home and in your community to improve our environment. And we'd like to thank Dr. Kopp again for joining us on our keynote for this spring. So we really appreciate you coming out, and we'll be wrapping up today. So thanks so much, everyone. Thank you for attending. Last call on the survey. I'm going to close the poll in the next couple minutes, so please take that before you leave. I'm getting lots of comments that you were excellent, and thank you so much for your presentation. So thanks again for joining Rutgers Cooperative Extension on our Earth Day Everyday webinar, and we look forward to keeping in touch. And thanks again so much for your support and for giving this talk today.
Thank you, Amy, and thank you, everyone. It's an honor to be your Earth Day special seminar speaker for your Earth Day Everyday series.
Yeah. All right. Well, thanks so much. I'll stop the recording.